Let's do another reaction with carbon nucleophiles. In the previous video, we did Grignard reactions and we analyzed how do we predict products, and sometimes we form chiral centers, so pay attention to the stereochemistry consideration whenever you're doing that. That's why knowing the mechanism is important. Now we're going to go here, now forming a cyanohydrin. So this is called, the product is called cyanohydrin. Okay, and so all of these nucleophiles attack with a carbon with a negative charge, and they form new carbon-carbon bonds. In fact, Grignard is a famous reagent, and Grignard, the chemist, won a Nobel Prize for that. Okay, now let's talk about cyanohydrin formation. What are we doing next is attacking with this. Now, typically, the condition for that is using the salt KCN and kind of a buffer. And what we have here is, again, the mechanism will go nucleophilic attack. Since I have an cyanide here, I'm going to do nucleophilic attack over here. So when I have that, I'm going to form the following. I'm going to do CN and O negative here. That is symmetrical, correct? So that, and after proton transfer here, the HCN is typically used to protonate, and we form the cyanohydrin because you have this, the cyano group in the OH. So cyanohydrin is that. This is symmetrical, as acetone or propanol, but if we make it unsymmetrical, and I add another carbon here, now you're creating a chiral center. Whenever you have a chiral center, since the geometry here is trigonal planar, when you're predicting products, you're going to get, I'm going to draw one, say, let's do CN, and I'm going to do metal here, OH. That is that plus the enantiomer. I also want to remind you guys something. When we draw structures like that, let's remember that when you have, this is an sp3 carbon, that's an sp2. When you have sp3 carbons, we typically draw two carbons, that's a tetrahedral geometry, 109 degree, 0.5. So that's methane. So we have two bonds in the plane, one in dash, one in wedge. So coming out towards you or in towards the opposite. So, and you need to always have then two lines in the plane or in two off plane if you did that. So in here you can determine the configuration. To determine the configuration here, you do priorities. And I'm always reviewing that because I think it is important that you keep that in mind always. Again, trigonal planar geometry, you can have the attack on both sides of the plane. You are having a chiral center because you have four different constituents at that carbon. And that means because the attack is from both sides, that you have a 50-50 mix of enantiomers, and that is a racemic mixture. Okay, and now assigning configuration of this cyanohydrin. So we're gonna do, notice here, that's a metal, so carbon, carbon, carbon. So my highest priority is the OH. And now when you have for the other carbons, we say in the first instance, we have 3 carbon atoms. And so we need to break the tie, right? So which I know is the greatest atomic number, but then I have carbon, carbon, carbon. How do we break the tie here? So this carbon is attached this to, we count the triple bond. We count 3 bonds to nitrogen, 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 nitrogen. This carbon is attached to 3 H's, so I'm going to draw HHH. In this carbon over here, I'm trying to break the tie, right? It's bonded to another carbon that's here into 2 H's. So now to assign priorities, since the first atom is the same carbon, carbon, and carbon, I look at what's attached to it. So I will have higher priority here because it's attached to 3 nitrogen. So that's my priority 2. My priority 3 is this one. Those are H's because here I have a carbon that beats the H. So that's my 3rd priority. And I have my lowest priority is the metal, so I'm viewing it correctly. So the configuration is 1, 2, and 3. Those are. Just doing that to review how do we do that. But what's important here when predicting product is that this is string on the planar geometry. If you are creating a chiral center, then your product is racemic.